Alright, I'm Jacob Torgerson, and as you can see, I'm doing mine on Euler's number, which is denoted as E. So, throughout the presentation, I'm going to talk about what is E, the history of it, where it's used in math, and then one really important real-life application. So what is E? E is defined as the limit as n goes to infinity of 1 plus 1 over n, all raised to the nth power. And this approximately is equal to 2.71828. It's irrational, and there's just a quote from the Pickover book that is from David Darling, and it says, E is possibly the most important number in mathematics. Although pi is more familiar to the layperson, E is far more significant and ubiquitous in the higher reaches of the subject. And when Euler discovered it, or he didn't really discover it, but when he called it by its name E, he found 18 digits, and now there's more than 100 billion digits. So its history, John Napier was from a lady from University of Little Rock in Arkansas, says that John Napier first used a constant in his work with natural logs back in the early 1600s. And then also Jacob Bernoulli and Gottfried Leibniz were also aware of the constant, but then Euler was the first to comprehensively study the number and call it by its symbol that we now know today as E. And the reason E was chosen as the number is not really known. Some people kind of say it's for Euler, but pretty much all the math historians don't think that's right, and they thought that maybe he was just going through the alphabet and A, B, C, and D were already used in other math problems, so he decided to use E. So there's a bunch of different areas where it's used in math. Exponential functions are a big one. Popular one is e to the x on a graph. The bell curve, or the normal curve in stats, it's used. The shape of a hanging cable or a standing arch. So like the last question on the handout is, the answer is the Gateway Arch in St. Louis. And there's a specific equation that goes along with the arch. Also used in problems of probability, counting problems, the study of the distribution of prime numbers, and it's obviously the base in natural logs. This equation was in the Pickover book, and it's e to the I pi power plus 1 equals 0. And the book says that it unites the 5 most important symbols of mathematics. So obviously e, I, pi, 1, and 0 are the 5. And then there's a Harvard mathematician from the book that's quoted as saying, "We cannot understand the formula and we don't know what it means, but we have proved it and therefore we must know it to be the truth." And so I guess there's not a whole lot of information in the book, but this link there was a little more, and so if you guys want to check that out. And it's known as Euler's identity just because it has Euler's number E in it. So compound interest is something that's pretty well studied in real life, and how you can gain money by investing. So compound interest is A equals P times 1 plus R over N to the NT. And then, so when you take the limit of this, as n goes to infinity, since p is a constant, you can take that out front, and then when you take the limit of this, it turns into the same as the first slide where you take the limit of 1 plus 1 over n to the n, and it turns into the number e. So then when you compound that continuously, it's p e to the rt. Because as you take, this is for if you would do it quarterly or yearly, but then this is continuously, because when you take the limit as n goes to infinity, you're constantly taking the interest rate. So then let's say we have $1,000 that we start with. Our first $1,000 we make as a teacher, we're gonna put in investment, and we're gonna get, let's say, 8% interest. So we go 0.08, and we're gonna put in there for 25 years. So that's so you end up with $7,389 and about 6 cents. So as you can see, you only invested $1,000 and you gained a little over 6,000 in a matter of 25 years with 8% interest rate. So I mean, this application's used all throughout economics and a bunch of real life problems. And those are my sources and my